Hi there, welcome to today's lesson. Today we are looking at how to use determinant to solve simultaneous equation. The normal simultaneous equation you know that we studied in commerce. There's a way you can use matrix to solve simultaneous equation. In fact, there are two ways. You can use either determinant or you can use inverse of a matrix, right? Now, but before we go on, don't forget to subscribe to our channel, click the subscription button, and don't forget to also click on the notification button, so anytime we add a video, you'll be the first person to be notified. And in case you have any question or anything to ask, you can always call us on 0549 169 506. Now, let's go on. So I have two simultaneous equations here, the normal comma simultaneous equation. You know, normally this becomes our equation 1, this becomes our equation 2. You use either the substitution or elimination method. Now, I believe that as of now, you know how to solve simultaneous equation using the normal elimination and substitution method, right? Looking at this particular one, now let's look at the solution. Let's look at the answers for this simultaneous equation so that we'll be sure that when we use the matrix or the inverse, when we use the matrix method, we are going to get the same answer. So here, the first one, I have x is equal to 3 and y is equal to -2. So for this particular one, I have x is equal to 3 and I have y equals -2. So let's see if we use our solution, whether we'll get the same answers, all right? And then the second one, I have y equals 7 and x equals 4. So this one gives x equals 4 and then y equals 7. All right, now before we'll be able to solve the solution for the first one, let's write this properly in an equation. So this becomes our first equation, and we have 2x minus y equals 8. This becomes our second equation. Now, for us to be able to use determinant to solve this one, we have to write this particular equation in a matrix form. Now, writing this one in the matrix form, we always write a coefficient. We always make sure x is in the same position and y is in the same position. Then we extract the numbers out. What I mean is that, so if we let, let's say m represent a matrix or the matrix of this equation, then we can say, writing this one in a matrix form, we have 3, look at it, 3, 2, this is what? 2 and then what? -1. Then we factorize the variables out. X, y equals 5 and then 8. Okay, so I've extracted this one, I've made it in a matrix form. So write the numbers. That's why you have to make sure that the x lie in the same column and then the y also lie in the same column. In any case, when you have y here and x here, you have to rearrange it and make sure they are all in alignment, right? So when you expand this, you realize that you get the same thing, because 3 times x will give me 3x plus 2 times y will give me 2y, right? You get the same thing. Now, since we made m our matrix, then it means m is equal to 3 to 2 and then what? Then 1. Is that also? Now, the formula for finding what we need is our x and our y. Our x is given by what we call the determinant of x all over our normal determinant, and then y is also given by determinant of y all over our normal determinant. So let's find, this determinant. Let's first find the determinant of the matrix, right? So we all know how to find determinant. So that of m, which is also equal to this, of this particular matrix, is given by, we have 3, 2, we have 2, -1, right? So finding the inverse of, determinant of this one, multiplying the leading diagonal, 3 times -1, we have -3, minus 2 will give us 4. So the final answer will give us what? -7. Okay, this is our normal determinant. Now, look at something here. If I want to find my determinant of y, or let's say x, my determinant of x, remember if you look at this represents my x column, this whole thing represents my x column, and then this whole thing represents my y column. Do you see that? Alright, so if I want to find the determinant of x, I will take the x component out and I'll come and replace it with what they are equated to. Right? So this time, my determinant of x, I first take all the x components. This one goes, the x goes out, and I replace it with what it's equated to. So 5, 8, and then this one is so 2, neg 1. Then I find the determinant. That becomes determinant of x. Okay? So this one becomes, let's find this determinant. This time, this is going to give me negative 5, minus 2 times 6 is going to give me 16. So the final answer is going to give me negative 21. Is that also right? Now, of course, since the determinant of x, we took x out and replaced it with what they are equated to, you expect that determinant of y, we take what? The y aspect out and replace it with what it's equated with, right? So determinant of y, I'm going to get, this time I maintain the x column, and then I replace the y with this. So here I have 5, 8. Then I find the determinant. Determinant is this, 3 times 8, that's going to be 24, minus 2 times 5 is going to be 10. So the final answer is going to give me 14, I think. Now, how do I get my x? I said x is given by what? The determinant of what? X over the normal determinant. Now here, my determinant of x is negative 21. My normal determinant, remember, is negative 7. This cancels this. 7 goes into 21 3 times. Do you see that my x is equal to 3? Do you see that? That's the answer. Now if I want my determinant y is given by the determinant of y over my normal determinant. Now, our determinant of y was negative 21 and our normal determinant is negative 7, right? Now, if this cancels, our determinant of y, is 14. It's 14 all over the normal determinant, which is negative 7. So 14 minus negative 7, I think it's going to give me negative 2. Do you see that we had the same thing here? So we have been able to solve this simultaneous equation using determinant method. Now let's quickly solve the second equation as well so that you understand better. Then after you solve questions on your own. So allow me to clean this particular aspect so that we can do the next one, right? Alright, so let's do the second one. The second one, I have 7x is equal to 3y plus 7. And then I have 5y is equal to 6x plus 11. You realize this is not arranged in a way I want it, so I have to arrange them well, right? So arranging this one in a simultaneous equation for I have 7x, you know all the variables comes here, right? Minus 3y equals what? 7. This is my first equation. Arranging this one, I have, you know, this positive, so when it comes here, it becomes negative. I have minus 6x plus 5y equals 11, this equation 2. And I know, as of now, you understand why I draw the x here, because they have to be in alignment. X has to be in alignment, y have to be in alignment, right? Now, so writing this one in a matrix form, matrix form, you know, we extract the numbers. So this one becomes 7, negative 3, negative 6, and then what? 5. And then we have our xy equals 7, and then what? 11. Okay? Alright, so we first find so if n is the matrix, this time we are representing it by n. 7, neg 3, neg 6, 5,